To deliver a video lecture on the topic of SAR in medicinal chemistry terms. For today, my objective is to explain or describe in the importance of medicinal chemistry, importance of SAR in terms of medicinal chemistry and as well as pharmaceutical industry. So I will shortly talk about some little more information regarding SAR. So basically, SAR, it is a structure activity relationship and basically helpful for the increase or enhancement of some physical properties and biological activity. Basically, SAR is structure activity relationship in the most important concept in drug development. SAR is the basically relationship between the chemical structure of a molecule and a biological activity. This idea firstly was presented by Crum Brown and Freshers in 1865. Okay, so basically SAR, it is a basic term used in medicinal chemistry and basically used for drug development and research purpose. Basically, important aspect of medicinal chemistry has been to establish a relationship between chemical structure. Chemical structure means what? Drug. Okay, drug chemical structure and their biological activity in terms of pharmacology aspects. Okay, in increased concentration, or we can say in recent years, various types of chemical structure can be modified and we can estimate or identify their chemical reactivity with the terms of physical properties, and these all the correlation can be helpful and relate their therapeutic properties via increase or decrease manner. Okay, so I will move to next slide. So here we can say that the complete or in a broad information regarding SAR. Okay, so there is a in recent years various types of success we have obtained in terms of SAR. Basically, we establish understanding between the relationship between chemical structure and biological activities in numerous areas. Basically, here is numerous areas means some types of disease in terms of drugs. Okay, especially in case of antibacterial drug, there are some confliction are there, and we want to improve some other drugs in case of antibacterial drugs. Okay, and some other activities like cancer, or we can say disease, viral infection, cardiovascular disease and mental disease also needed some new agents and approaches for their treatment and for preventing their illness, or we can say in terms of drug, we have to modify these type of drugs to distinguish their physical property as well as their biological activity, and also want to increase therapeutic efficacy in terms of decrease or reduce toxicity. Okay, most of the drugs are act in various types of sites. Some of are binds to specific site such as enzyme or receptor, and these compounds which have similar structure we have used in modifications, and these compounds which have a similar structure, they also give same pharmacological activity, and these compounds we were used in as a lead compound in terms of drug development. Okay, however, they usually exhibit different potency and unwanted side effects, and in some cases different activities. Okay, there are some compounds which have similar structure, chemical structure, and they also give pharmacological activity, same pharmacological activity, but sometimes they also use, sometimes they also give some unusual effect that just like side effect or increased toxicity or increased some potency. There is a basic difference in potency of a drug and a modified compound. Okay, basically these structure related to different type of related to different type of lead, and these all process called as structure activity relationship. Okay, so further I will move to next slide. Okay, here I will also give some brief information regarding SAR. Basically, SAR, structure activity relationship, usually determined by some making some minor changes or major changes in structure. Here we use some drug which already useful in some diseases, and we have to modify by via making some major or minor changes in these type of drug that will help to make some other lead compounds, and these lead compound also give some other biological activity or as well as increases the previous biological activity, which decrease the toxicity and side effects. Okay, there is some traditional ways to investigate the SAR, or we can say process the SAR are carried out by making large number of analog of the lead and testing them for biological activity. We can say here that one compound we used to take some compounds which also have their biological activity, and we have to take them, and there is some we make some minor changes in their chemical structure, uh, so that they can also uh, act as an analog of particular drug and also give their biological activity with less toxicity or reduced toxicity. Okay, next my next point is many of the years numerous lead compounds have been investigated, and from the mass of data it is possible to make some broad generalization about biological effect of specific structure changes. And over the years of in recent years, various types of compounds we identified and investigate in terms of lead, and we can collect these type of we have collect these type of lead compounds from mass of the data. Okay, and they all the compounds giving some broad generalization or broad information regarding biological activity and from the specific structural changes, and these changes may be conveniently classified as, or we can say in the changement or minor changes in the chemical structure. For there we have I have included 3 points, that is the size and shape of the carbon skeleton, the nature and degree of substitution, and the stereochemistry of the lead. Okay, these 3 points major plays major role in the SAR, or we can say these 3 points gives us lots of lead compound from the parent compound. Okay, these are basic important techniques we have to use in drug development, from and give from parent compound to new compound, giving new compound, uh, biologically active ones, and as well as less toxic. Okay, uh, basically the selection of the changes requires to produce analogs of a particular lead is made by considering the activities of the compound with similar structure. And there is a one more thing, we have to use these type of compound uh, these type of compound that have a similar chemical structure as well as have similar pharmacological activity. Okay, and also the possible chemistry and biochemistry of the intended analog. Okay, so now turn to next, that is again some examples for the explanation of SAR. There is some good examples I will take to describe my points. Uh, like first point is replacing a hydroxyl group with a methyl group could reduce the water solubility of the analog and its ability to form hydrogen bonding. Okay, so when we use one compound that have a hydroxyl group and we replace that compound with another methyl group, can reduce the water solubility and as well as it to form ability to form hydrogen bonding. Okay, the former could reduce its ease of absorption and that will help to bind target site in a specific manner. Okay, it could improve the transport of the drug through membranes and also introduce changes in the metabolism of the drug. Okay, next example which I will take, that is oxidation of methyl group to a carboxylic group could increase the rate of metabolism. If we use one compound that have a methyl group and here we will change some we can make some minor changes and to convert into carboxylic group, that will also help to increase the rate of metabolism. All these effects could result in loss of activity or a reduction in unwanted side effect. Okay, further consideration is the size of the analog. Okay, so there is a it's a very important point that size of analog also matter to in terms of drug development and in terms of changes of physical property and in terms of changes its biological activity. Changing the structure of the lead could result in an analog that is too big to fit its intended target. Okay, so if we can make some changes in which chemical compound is now turned to much more bigger analog that is too big, it is not fit to target side and maybe that will decrease his or that will decrease their pharmacological activity. Okay, there is one more thing, computerized molecular modeling. There we have to use some computer programs that will help to uh, correlate between drug structure and receptor site. Okay, they can be used to check this provided that structure of the target is known or can be simulated with some degree of accuracy. Basically, in molecular modeling, we have used chemical structure of a compound, and we will then further it will correlate to receptor site, and we have to bind them. We can further proceed that they both are bind. If there is some process furthermore proceed, then it will be accurate, and if the binding process will not be occur, then it will not accurate, or we can say the compound lead compound is not good for particular target site. Okay, traditional SAR investigation procedures are useful tools in the search for new drugs. However, they are expensive in both personal and materials. Uh, Consequently, a number of attempts have been made to improve on traditional structure activity relationship or investigation with varying degree of success. Okay, so now I will move to next slide. uh, uh, it is very important point, changing the size and shape. Here we talk about compound structure and compound size and compound shape. Okay, the shape and sizes of a molecule can be modified in a variety of ways, and various type of changement we can proceed in the chemical compound or drug molecule, and these are helpful to make some better or lead analogs. First one is changing the number of methylene group in chains and ring. Okay. Second one is decrease or increase the degree of unsaturation. Third one is introducing or removing a ring system. Okay. These are points basically useful to create some important, or we can say lead, specific lead compound for a particular uh, activity. And I will also describe these compound later. So further move to next slide, that is changing size and shape, basically introducing chain, branched chain, or we can say or and different sized rings, and the substitution of chains for a ring and vice versa may also have an effect on the potency and type of activity of an analog. Okay, basically a drug compound, whenever we have introduced some branching or a different size of ring or a substitution of another chain in a ring, that may also have give some better pharmacological, or we can say biological activity, and they also give some different type of lead analogs. It will helpful for giving these type of analog which are helpful in different type of biological activity. For example, the replacement of the sulfur atom of the antipsychotic chlorpromazine by CS2 produces the antidepressant clopipramine. Okay, so there is a short replacement or a minor replacement, that is sulfur atom then change into CS2 group, that is produces antidepressant activity. Okay, previous one is antipsychotic activity. Okay, now I will move to next slide, that is changing the degree of unsaturation. Basically we have take lots of chemical compound, or we can say chemical drug, chemical structure that have double bonds. If we can we can create some minor changes like removal of double bond, that is in that will help to increase the degree of flexibility of the molecule, and which also make to easier for the analog to fit into an active compound, active site. Okay, or we can say active and receptor site, by making up a more suitable conformation. Okay, however, an increase in flexibility could also result a change or loss of activity. Either the activity will be more beneficial, or we can say more in increased form, or in decreased form. Okay, the introduction of a in next point, and there I will use to say that 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 introducing a double bond that will increase the rigidity of the structure. It may also helpful to introduce the complications of E and Z of isomer. Okay, which could have quite different type of activity. Okay, these analogs produces by the introduction of unsaturated structure into a lead compound that may exhibit different degree of potency or different type of activity. For example, the potency of prednisolone is about 30 times greater than that of its parent cortisol, which does not have carbon-carbon double bond. Okay. Next point is the replacement of sulfur atom of the antipsychotic phenothiazine drugs by a uh, Celsius group gives the antidepressant dibenzepine drug. Okay, so there is a there will minor changes gives a different type of biological activity. Okay, if the introduction of carbon carbon double bond group will often give analogs that are more sensitive to metabolic oxidation. This may or may not be desirable feature for the new drug. They will not they may or may not be give some biological compound or not. Okay, furthermore, the reactivity of carbon carbon frequently causes the analog to be more toxic than a lead. Okay, now I will move to next slide. Introduction or removal of a ring system. It is also an important point in terms of SAR, basically, or we can say in drug development or in research field. The introduction in various type of chemical compounds, if there is introduction of a ring system, that will change the shape and increase the overall size of a analog. Okay, the effect of this changement uh, on the potency and activity of the analog is not generally predictable. Okay, after the changement we will investigate, or we can say we will summarize the results. So however, the increase in size can be useful in filling a hydrophobic pocket in target site. Okay, so there in every type of drug there is a three type of target site, like hydrophobic, hydrophilic, and third one is receptor site. Okay, so the increase in size can be useful to filling a hydrophobic pocket in target site, which might strengthen the binding of the drug to the target. Okay, it will helpful to create a strong bond between a target site and the drug binding site. Okay, so I will move to next slide. That is a very common and new point, that is a new substituent, introduction of new substituent. Basically, introduction of these type of substituent can be done in a particular chemical structure, and that chemical structure also uh, helpful in some type of diseases, to cure some type of diseases. Okay, the incorporation of a methyl group, or we can say if introduction of a methyl group can also give three types of effect, generally gives three type of effect on the rate of metabolism of a analog. That is, first one is an increased rate of metabolism due to oxidation of methyl group. Okay, next one is an increase the rate of metabolism due to demethylation by the transfer of methyl group to another compound. Next one is to decrease in the rate of metabolism of the analog. Okay, these are the some important point in the introduction of a new substituent. Now I will move to next slide. That is there is a some few examples I will include it. That is tolbutamide, and after the oxidation it will be less toxic. Okay, so here is a methyl group bound to an aromatic ring or a structure which increases its reactivity, may be metabolized to a carboxylic acid, which can be eliminated more easily. Okay, example, I already explained that antidiabetic tolbutamide is metabolized to its less toxic benzoic acid derivative. Okay, next one is demethylation. It is more likely to occur when the methyl group is attached to a positively charged nitrogen and sulfur atom. Although it is possible for any methyl group attached to nitrogen, oxygen, or sulfur atom to act in this manner. Okay, methyl group also can reduce the rate of metabolism of a compound by masking a metabolically active group. Okay, thereby giving the analog a slower rate of a metabolism than the lead. Okay, for example, the action of the agriculture fungicide Nebamis due to its being metabolized to the deactive diisothiocyanate and methylation of Nabam yield an analog that is inactive because it cannot be metabolized to the diisothiocyanate. Okay, next slide. That is again methyl group, some changes in chemical structure related to methyl group. Methylation can also reduce the unwanted side effect of a drug, and the most important example for to describe this line is paracetamol. All the NSAIDs, we all know that all NSAIDs give some hepatotoxicity after taking these type of drugs. Maybe patient feel some toxicity, that is called as hepatotoxicity. So introduction of introducing mono and diorthomethylation with respect to the phenolic hydroxy group of a paracetamol produces analog with reduced hepatotoxicity. It is believed that this reduction is due to methyl group preventing metabolic hydroxylation during metabolism hydroxylation of these orthoposition. Okay, next one is introduction of a new substituent in terms of halogen. Okay, so halogen, if we introduce halogen group, then what will occur? The other aliphatic carbon halogen bonds are weaker, their reactivity increases down the periodic table. They are usually more chemically reactive than a aliphatic carbon hydrogen bond. So consequently, the most popular halogen substitutions are the less reactive aromatic fluorine and chlorine groups. However, the presence of electron withdrawing ring substituents may increase their reactivity to unacceptable level. Trifluorocarbon groups CF3 are sometimes used to replace chlorine because these groups are a similar size. Okay, the size of trifluorocarbon, and if we can create the analog that have a chlorine group in place of fluorine, they are in terms of chemistry they both having similar size. These substances avoid introducing a very reactive center and hence possible site of unwanted side reaction into the analog. For example, the introduction of the more reactive bromo group can cause the drug to act as an alkylating agent. Okay, so maybe the substitution of these type of halogen groups in the drug compound and these type of analogs maybe give some different type of activity, biological activity. Okay, so now I will move to next slide. That is hydroxy group. That is also in points of new substituents. In this point, basically, here we have to introduce, we will introduce some hydroxy group in the chemical structure of the lead that will normally produces that type of analog which increase the hydrophilic nature and lower basically hydrophilic if properties increase, that so it mean to say that lipid solubility will be decreased. Okay, it also provide a new center for hydrogen bonding which could influence the binding of the analog to its target site. For example, Orthohydroxylated minopril analog binds more effectively to M1 muscarinic receptor than many of its non-hydroxylated analogs. Okay, the introduction of hydroxy group also introduces a center that, in the case of phenolic group, could act as a bactericide, whereas alcohols have narcotic properties. So here also the conclusion of the substitution of hydroxy group is that in minor changes or introduction of hydroxy group or will introduction of hydroxy group also gives some that type of biological effect which will which differ from the parent compound, which activity will differ from the parent compound. Okay. However, the presence of hydroxy group opens a new metabolic pathway that can either act as a detoxification route or prevent the drug from reaching its target site. Okay. Now I will move to next slide. That is introduction of some basic groups. Okay, if we introduce some basic groups, may also increase the binding of an analog to its target by hydrogen bonding between the target and the basic group. Okay, okay. If we increase the binding, increase the hydrogen bonding, uh, or we can say binding site of a, we can increase the binding site of the analog. That will happen when we introduce some basic groups in an analog. So, however, a number of drugs with basic groups owe their activity to salt formation and the enhanced binding that occurs due to the ionic bonding between the drug and the target. And for the explanation of this point, I will use one example. Basically, it is believed that many local anesthetics are transported to their site of action in the form of their free bases, okay, but are converted to their salts which bind to the appropriate receptor sites. Okay, after the conversion in some analogs or after the conversion in some basic groups, it will help to bind a compound or chemical compound to a appropriate receptor site of the body. Okay, incorporation of aromatic amines into the structure of a lead is usually avoided because aromatic amines are often very toxic and carcinogenic. Okay, basically aromatic amines in a structure that will lead to avoid aromatic amines that will also very toxic and carcinogenic for a health. Okay, so I will move to next slide. That is introduction of a new substituent in terms of carboxylic and sulfonic acid group. If here we if we use some changes like introducing a carboxylic group or a sulfonic group in a drug, that will also give a some uh, some type of uh, specific leads for a particular activity or may be helpful to change their physical properties as well as pharmacological properties. May be also helpful to decrease or increase the toxicity. Okay. However, the introduction of carboxylic acid group appears to have less effect on the activity of large molecules. Okay. Basically, when we introduce a carboxylic acid group to a chemical compound, and that type of analog have less effect on the activity of large molecule. Sulfonic acid groups basically not have any effect on the biological activity, but will increase the rate of elimination of an analog. It will help to reduce toxicity in the body. Okay, so these are the some examples which also helpful to introduce newer compound, that is phenol, salicylic acid, phenyl ethylamine, phenyl alanine. Okay, now I will move to next slide. Uh, that is changing in the existing substituent of a lead. Okay, um, there also we will use some changes in a analog or a lead compound. That is analog can also be formed by replacing an existing substituent in the structure of a lead by a new substituent group. Okay, basically there is a when we change chemical structure by the removal, or we can say replacing one group to another, it will give some potent compound. Sometimes it will give some potent compound, sometimes it will give uh, that type of compound that will not help to cure or prevent any disease, or sometimes it will give that type of compound which will help, not help in any type of biological activity, also give some major type of or increases some type of toxicity. The choice of group will depend on the objective of design team. It is often made using the concept of isoesters. What is isoesters? Basically, isoesters are a group that have similar physical properties, or physical properties like chemical and physical properties, and also have same biological activity. As a result, they can exhibit similar pharmacokinetic and pharmacodynamic properties. In other words, I can say that the replacement of a one substituent by its isoesters, it most likely to result in the formation of an analog with the same type of activity as the lead than the totally random selection of an alternative substituent. Classical isoesters. Basically, isoesters are two types: classical and non-classical. Classical isoesters were originally defined by Unmeyer as being an atom, ion, or molecule that had identical outer shells of electron. This definition also have broadened to include that these type of compound have similar structure, similar physical properties, similar chemical properties, also have similar biological activities, and these are called as bioisoesters. Okay, so now I will move to next slide, and that is all about SAR. A large number of drugs have been discovered by isoesters and bioisoesters interchanges. That is some example I will include it here. The replacement of 6-hydroxy group by hypoxanthine by thiol group gave the anti-tumor drug 6-mercaptopurine, whereas the replacement of hydrogen in the 5 position of uracil by fluorine resulted in fluorouracil, which is also an anti-tumor agent. However, not all isoesteric changes yield compound with the same type of activity. Replacement of sulfur of the neuroleptic phenothiazine drug by either these compounds produces dibenzodiazepines, which exhibit antidepressant activity. So that all about that's all about for SAR. And basically, the main motto of SAR is to develop some drugs in terms of medicinal chemistry and give some that type of compound or lead compound that will help to prevent or give some cure from various types of disease. Okay, and basically SAR structure activity relationship. Uh, our basic term is to relate between structure of a chemical compound and its basic relationship, yeah, or correlation between with the pharmacological activity. Okay. So there is some changes that will help in pharmaceutical industry, that will help to give some that type of researches to help in research field, and also they help into broaden if they help in research, if they help to giving some broadened ideas to researcher. So that's all about from my side to have about to have to say about the SAR. Thank you all.